You ever thought about taking a drink of water and what it is and what it used to be? I mean, it used to be we had to go and find clay from a riverbed and then sift it and refine it until we got a product that we could actually make a vessel out of. And it was precious, you know, being able to carry water from one point to another. With long before aqueducts, you know, we were using clay vessels to transport water. Now we make them in a laboratory. You know, we have a huge warehouse that has machines that take raw plastic and then they heat it up and they extrude it through a machine into a closed system that has molds that are cooled, and then the hot plastic is formed into the mold, dropped into the mold, and the mold closes on it. Pressurized air forces the plastic out, and then it through, you know, the mechanical process is dropped off, gone down a conveyor, inspected for quality, packed into a box, shipped off to the producer, and filled with whatever kind of goo that we put in there, water, ketchup, Coca-Cola, whatever it might be. And we think not of, you know, this whole process. And in fact, it's so often forsaken that it just gets tossed off on the side of the road, you know, to clatter around and become just that much more eye garbage that we don't put any thought into. Well, we also have a lot of other things that we don't consider anymore, other synthetics that, you know, well, once upon a time that plastic was single-celled animals that were drawing carbon out of the atmosphere so that multi-celled animals would actually have a habitat in which they could evolve and thrive. Think about now, today, where that we have so many things that we produce in a lab that we don't think about anymore, such as when we eat dairy and cheese. Well, cheese used to require a product called rennet, which when the cow would give birth, we would take the calf and slaughter the calf. The calf would eventually become veal. But in the fourth stomach, before the calf was weaned, there was a product that we used, chromasin. Okay, so we took the chromasin, and that allowed the casein and so forth to be processed, fermented, so that we could make cheese out of it. Eventually, in the 1980s, we had a fermentation produced chromasin, right? So then we no longer required the slaughter of the calf. Well, I guess that opened up some opportunities. We could take that cow that would have been slaughtered so that we could make cheese, and instead then we could grow that cow up and make dairy, or we could go ahead and make veal. But it no longer required, and no one thought anything of it. You know, no one thinks anything of it today that we use this lab cultured chromasin in order to produce our cheese. Testosterone was similar. You know, we first didn't even know that testosterone was the hormone, was the chemical. We just had mad scientists who were removing testicles from dogs and grafting them onto humans, and noticing that there was, you know, what at least appeared to be a benefit. It wasn't until 1935 that testosterone was identified as a hormone, and within that same year we synthetically made it. So we no longer needed to kill dogs in order to get our testosterone, or pigs or whatever. We were able to create it in a lab. And what did we do with it? Mostly it's Machiavellianism. Well, the same with insulin. You know, insulin was first isolated in 1921 and was, you know, used for treating diabetes. You know, especially type 1 diabetes. You know, type 2 diabetes, we didn't come to a full understanding of its operational process for a while. But in 1964, we had the first synthesized insulin. This was still a pig insulin, but it was still treated and used the same way as it would be otherwise if we harvested it from an animal, except it's cleaner. You know, we didn't have anything else that needed to be removed from it. We had a synthesized product that we could use that didn't, have to, we didn't have to filter out any bile or anything else that might have been associated with it. And then in 78 is when we had the first human synthesized insulin, and that's what we use today. We don't think about it anymore as coming from a source that was, not biological, as if the pig insulin was better than the human insulin, which was, better than the synthesized insulin, which in all cases the synthesized form was cleaner. Epinephrine was the same way. We used to harvest that from calves and sheep. Epinephrine, the same thing that we use whenever you need an EpiPen, like you are allergic to peanuts or a bee sting and you need the EpiPen. Well, that was, first sourced and recognized in the 1890s, and recently we know how to, thyroxine is another. That was for, we used to dry out the thyroid glands from animals, calves and sheep, and dehydrate it into powder, which we would then use to treat hyperthyroidism. It's not done that way anymore. We don't have to. We got a cleaner, easier source that we can use for that. Hyaluronic acid was isolated in 1934 from bovine eyes, from cow eyes, and then we've come to realize we can use that in eye surgery, also in cosmetic surgery, and for osteoarthritis. Well, we no longer harvest cow eyes in order to get this. We create that in a lab, and no one thinks anything of it. Streptokinase was isolated from bacteria, and we use that for blood clots. Okay, so whenever we got a blood clot going on, we can inject the streptokinase into the system, and so this is very helpful in heart attacks, mitochondrial infractions. Part of the heart attack, besides the clogging of the artery itself with our dietary consumed fat, is the blood clotting. So we inject this into the person, and it relieves the blood flow. So for strokes or heart attacks or whatever it might be. Also collagen. It's just so many things, but collagen, used to be exclusively sourced from animals, and we don't do that anymore. We can make that in a lab with a more pure alternative. All of these lab created alternatives, insulin to collagen to testosterone, it's all easier and more pure to make, especially on a grand scale that we do now. So these days we have the opportunity to totally bypass the cow in making cheese. So we can make casein in a lab. We already know that we can eliminate the rennet with this on enzyme, so we don't need that. And if we make a cultured cheese such as this, we can also control what kind of fats we put in there, what kind of sugar, so we won't have the lactose intolerance that we might otherwise have. We can replace that sugar with a glucose-based sugar, or fructose if we want, and the fats we can bypass the saturated fats. Additionally, there's no cholesterol. We can control cholesterol. There is no industrial toxins. There's not going to be any DDT or herbicides or pesticides that are also just going to be inherent within the current factory farm model. So we have this opportunity, and it's fast coming, and you probably aren't even going to know that it's here, because there's not a cultural pushback from it. As this has become available, so have other things. We're hearing today that animal lab testing doesn't need to be done because we can culture the cellular structure within a lab. We don't need to grow a monkey to grow monkey brains anymore to test whether this medicine is going to affect primates or not. We can culture the cellular makeup of the monkey brain in a lab created medium and test it directly. So or dogs. A lot of times we're using dogs in experiments too. So many of these things can no longer require the actual animal in order to. So, and that's a torture. A lot of times these animals, after they're done, even though they would have a life that was remaining to them, they often are not. They're just euthanized. So within this idea, this emerging technology that we have, we also have lab-grown meats. We have cultured meats that we can grow. If I could quote Winston Churchill in his famous 50 years hence doctrine, he wrote, "We shall escape the absurdity of growing a whole chicken in order to eat the breast or wing by growing these parts separately under a suitable medium." We have that opportunity to do that today. We can grow flesh, we can grow protein, we can grow animal muscle within a medium that doesn't require the intensive infrastructure that is part of what our current model is, or current factory farm model. The factory farm model is the most efficient way to produce this protein. First of all, our emerging science, our lifestyle medicine, is showing that reducing or eliminating these products from our diet is the most helpful way for us to live. But many people are not willing to do so. They would rather incur disease than to avoid disease. They would rather have this comfortable medium where that they put their mayonnaise and ketchup than to have a plant-based alternative. And that's largely just a political push. But such as it is, these new cultured meats, these lab-grown meats, it's not a plant-based meat any more than a cow's shoulder is a plant-based meat. It is plant-based in that the original nutrition was derived from a plant, but then within the machinery, within the lab of the cow, it was turned into muscle. In doing that, we got rid of all the fiber and much of the nutrition, so that we could have a calorie-rich, calorie-dense platform upon, which, in order for us to have flavor, it's, flavored by plants, and then we have to cook the muscle in order for us to be able to taste it. All that set aside, when we become comfortable enough to consume these materials within our culture, we will also be bypassing the industrial toxins that are absorbed within the animal. We have the lead and the mercury and the arsenic and stuff like that are just part of the industrial processing of the animal where the animal grows, because they're in these super confined industrialized areas. We'll also be bypassing the embedded toxins, the DDT, that was, that's just still in the environment, still especially part of dairy production. Like, dairy is the most highly associated pathway by which we have associated the formation of Parkinson's disease and other cognitive decline. So we eliminate the DDTs and the Roundups and all of that as being coalesced within the production of the meat. We also have control over what kind of fats that we can probably bypass the saturated and trans fats, which are the associated clogging of the arteries. This is what causes arteries to clog that we eat, and not necessarily doesn't have to come from animal source. Broccoli has saturated fat; it just doesn't have nearly as much as what we currently eat. We can control the amount of fat because the GMO animals that we eat, the cows, they don't resemble a wild oxen or a wild buffalo. They're 60% fat, 70% fat. Even when we buy a lean version, what we're told is lean, we're still eating an animal that is composed of, 60% fat, where if we ate a moose or a deer or something like that, it's going to be like a 10% fat ratio in the muscle. So we have control of the fat, but we could also just substitute that fat for a more desirable high density fat. These are low density fats that we're eating that are problematic and create diseases like fatty liver disease and heart disease. We could swap that out for intermediate or high density fats, and also control the cholesterol. We could just eliminate cholesterol altogether so that there's no cholesterol within the food, no hormones within the food, no added hormones within the food, no antibiotics, because we don't need antibiotics in order to keep the animals alive long enough to grow them up to full size to get the most money. And the zoonotic diseases will be eliminated. The fact that these animals are grown in such closed conditions that they pass diseases back and forth, like bovine leukemia virus. Bovine leukemia virus is associated with breast cancer. It's associated with leukemia. It's associated with, and it's in all of the livestock, all the bovine livestock that we have in the United States. Europe controls for this. The United States does not. And mad cow disease, these type things that are just part of what we've accepted as what it takes to have dollar menu meat. There's also, unfortunately, an embedded culture of torture that is part of what our food value has become. We accept that torture is okay, the selective killing is okay, and believe it or not, this travels up the food chain. It's not just something where that we say, well, it's wrong to kill dogs, but it's okay to kill pigs. It's something that we accept within our own species too. It is a driving force of what gave us the ability to say that one person had a whole soul while another person only had 3/5 of a soul. So the person with 3/5 of a soul is okay to be a slave, while the whole soul is not. Without these other levels of acceptance where that we gathered within ourselves, it's okay to do this to a pig but not a dog. We also unknowingly, subconsciously accept that these things are okay within our own species. That brings us to a culture clash like we see in many places today, where that, one person believes in one religion, the other person believes in another, and so they fight to the death because one thinks the other one's wrong. We're able to more easily accept that because of what we accept with the other life upon the earth, the other creations upon the earth, that we say that this one has value and this one does not. That is a subconscious subliminal culture, a death culture that we accept. And as we move away from animal agriculture, from farming animals exclusively for a taste value that we don't need in order to thrive, we'll also move away from this death culture. So we have a lot of opportunity with the emerging lab-grown or cultured meat to bypass dead zones in the oceans,